So dear students, today I will discuss about electric field due to continuous charge distribution. Okay, in the last class I have discussed about electric field due to some discrete charge distribution. Sometimes the charges are at the corner of the triangle, at the corner of the square, but today I will discuss about continuous charge distribution, and due to continuous charge distribution the electric field at a certain point. And the continuous charge distribution is actually distributed throughout certain geometry. Sometimes it will be distributed along wire, or you can say along rod, or sometimes it will be distributed along the perimeter of the circle. Sometimes it will be on the surface of the disc. So I will discuss one by one for all the cases, and I will actually derive the expression for electric field at a particular point due to various kinds of charge distribution. Okay. And in the first case I have taken here the electric field due to uniformly charged rod. Okay, and we have first we will discuss at axial point. Okay, then I will discuss obviously at perpendicular bisector, at the point along the perpendicular bisector, or at perpendicular distance you can say. So I will discuss that case later on, but first I like to discuss at an axial point. So what will be the electric field due to this charge rod at the point P, which is at a distance a from one end of the rod. Okay, and the rod is uniformly distributed with charge q, and the length of the rod is L. So first the term you can define that what is the charge per unit length. Okay, so you can say the linear charge density. Okay, or the charge per unit length. So linear charge density here you can write. So what will be the linear charge density? Lambda is equal to q by L. You can write it first. So here I have taken small l, so you can write it q by small l. Okay, so this is the charge per unit length, that is the lambda. Now what we have to do? We have to find out the electric field at this point. So to do this, the very first thing is we don't know the electric field due to this kinds of extended charge, but we know the electric field at a particular point for point charge. So we have to take a small charge element over here, okay, small charge element, and that is the charge of dq, so that we can treat this dq as point charge. Now from this dq, if we treat this dq as point charge within the distance, within the length dx, you can say. So this length let me take as dx. So in dx length there is charge dq, and this dq is so small and this dx is also so small that we can treat this dq as point charge. So if this dq is point charge, and let me take the distance from p to dq is just x. So if we take this distance as x, then what will be the electric field due to this point charge dq at this point p? We know from the point charge, the electric field due to point charge, we know the expression for point charge. Okay, so we know if here is a charge q, suppose here is a charge q, point charge q, and at a distance r, or if at a distance x, we know what is the electric field here. So instead of q, if we use dq, then the electric field at this point p will be same as here. So we know for point charge it will be E is equal to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into dq upon x square, dq upon x square. We know this expression. So this is here actually not E, here for this case it will be dE, it will be dE. Now what will be dq? So lambda is equal to q by L for the whole rod, but if you talk about this point, only for this point, then it will be dq by dx, because here the length is dx and the charge is dq, but for the whole rod the charge is q and the length is L, but here charge is uniformly distributed. We have taken electric field due to uniformly charged rod, so the charge is uniformly distributed. That means at each and every point the charge per unit length is same. So whatever you can say lambda is equal to q by L or lambda is equal to dq by dx, this will be same. So you can write dq, you can write dq in terms of lambda and dx. So you can write dq is equal to just lambda dx. Okay, you can write dq as lambda dx, and you can substitute here. So dE will be just 1 by 4 pi epsilon naught into lambda dx upon x square. So this is d, and this d is for this small element dq. Now if we move this dq from this point to this point, okay, we can move this dq. The dq will be near point for p when it will be at this point, and when it will be at this point, then the distance from p is a. But when it will be at this point, dq will be at this point, the distance from p will be a plus l. So when dq will vary from here to here, the x will vary from a to a plus l. So to find out the total electric field at this point according to superposition principle, we have to integrate this expression. So the net electric field at point P, you can write here the net electric field, okay, the net electric field at point P will be what? E, and that will be integration dE, okay, integration dE, and that will be 1 by 4 pi epsilon naught. We can take common 1 by 4 pi epsilon naught and lambda, because lambda is also constant. This is uniformly charged distribution. So it will be just lambda upon 4 pi epsilon naught is constant, and the integration will be on dx upon x square. Now I have said earlier that the limit will vary from here to here. So when dq will be here, the distance from p is a, and when dq will be here, it will be just a plus l. So the limit of the integration is from a to a plus l. Now you can integrate easily, because it is a very simple integration. 1 upon x square is minus 1 by x. So it will be lambda upon 4 pi epsilon naught into integration of 1 by x square is minus 1 by x, okay, and the limit will be a to a plus l. Now you can simplify. Okay, so this will be just, you can write, so it will be just lambda upon 4 pi epsilon naught into, first you can write upper limit, but here negative sign, so we can substitute lower limit first. So 1 by a minus 1 by a plus l. Okay, now if you simplify this again, so it will be just lambda upon 4 pi epsilon naught into, so it will be a into a plus l, and it will be a plus l minus a. So you will get from here that it will be just lambda, you can substitute the value of lambda also, that is q by l. So it will be q upon 4 pi epsilon naught l, okay, and from here this a and a will be cancelled out. So it will be just l divided by a into a plus l. So this l will be cancelled out. So it will be q upon 4 pi epsilon 0 a into a plus l. So this will be your final expression, electric field at this axial point. So you can write it like this: q upon 4 pi epsilon 0, okay, into a plus l. So this will be your final expression. Okay, so this is the electric field at this axial point.